Consider for a moment what it means to find footprints in fresh snow, but only the print of a single boot. No matching pair, no trail leading anywhere, just one impossible mark where nothing should exist. On August 15, 2025, astronomers at the European Southern Observatory detected something that shouldn't be there. Not in the sense of being unexpected. We've grown accustomed to interstellar visitors since Oumuamua first crashed our solar system's private party, but 3I Atlas was different. It was leaving that single boot print in the cosmic snow. Here's what makes my pulse quicken. The Very Large Telescope in Chile's Atacama Desert picked up spectral emissions that read like a metallurgical signature from Earth. Nickel. Pure nickel vapor streaming from what appeared to be a dirty snowball traveling at 47 kilometers per second through the void. The most straightforward explanation would be simple sublimation, frozen nickel compounds vaporizing as the comet approaches our sun. This makes perfect sense from a chemical standpoint. Interstellar space is cold enough to freeze almost anything, and nickel-bearing minerals exist throughout the universe. But here's what keeps me staring at the data. Where's the iron? On Earth, in every meteorite, in every cosmic dust grain we've analyzed, nickel and iron are inseparable partners. They're forged together in stellar cores, scattered together in supernovae, and travel through space as eternal companions. Finding nickel without iron is like finding smoke without fire. Technically possible, but it makes you wonder what you're not seeing. What if this isn't about natural processes at all? What if we're looking at the chemical signature of manufacturing? In terrestrial metallurgy, separating nickel from iron is routine industrial practice. We do it in refineries across the globe, every day. The Mond process, electro-refining, selective oxidation. We have dozens of methods to produce pure nickel, but these require sophisticated technology and controlled environments. Of course, there could be exotic astrophysical processes we haven't discovered yet. The universe has 4 billion years of stellar evolution on us. It's entirely possible that some unknown mechanism could naturally segregate these elements in interstellar space. Without more data, both possibilities remain tantalizingly open. But as 3I Atlas continues its journey toward the inner solar system, that single footprint in the cosmic snow demands an explanation. The first rule of reading scientific papers is learning to decode what scientists don't say. It's like reading diplomatic cables. The real message often lives in the careful gaps between words. When NASA's Jet Propulsion Laboratory issued their preliminary report on 3I Atlas, the language was technically precise but emotionally sterile. Unusual spectral characteristics warrant further investigation. The European Space Agency's statement was similarly measured. Observations reveal interesting compositional anomalies. This is the voice of institutional caution, and I understand why. In 2017, when Oumuamua tumbled through our solar system with its own set of mysteries, the internet exploded with speculation about alien technology. Scientists spent more time debunking conspiracy theories than analyzing actual data. They learned their lesson about public communication. But here's what caught my attention in the preprint archives. The raw data tells a more urgent story than the press releases suggest. The Hubble Space Telescope captured 3I Atlas in multiple wavelengths during its August observations. The visible light showed a typical comet: nucleus, coma, nascent tail development, standard celestial behavior. But shift to the ultraviolet spectrum, and something else emerges. The UV emissions don't match any known cometary composition. They're too concentrated, too uniform, too purposeful. Dr. Elena Kowalski at ESO noted in her preliminary analysis that the emission patterns suggest a highly organized internal structure. In diplomatic scientific language, this translates roughly to, what we're seeing doesn't look random. Random is what we expect from nature. Chaotic ice sublimation, irregular dust release, asymmetrical gas clouds. Comets are messy, unpredictable objects, gravitationally disrupted snowballs with no concern for aesthetics or efficiency. But 3I Atlas appears to be releasing its materials in precise measured quantities. The nickel emissions pulse with almost mechanical regularity, every 4.7 hours like clockwork. The most logical explanation would be rotational modulation, the comet spinning and exposing different surface compositions to solar heating. This is common behavior. As various regions face the sun, they heat up and release different materials based on their local chemistry. Yet something bothers me about that 4.7-hour period. It's not quite random enough. Most comet rotation periods fall into a broader range, anywhere from a few hours to several days, depending on their formation history and gravitational encounters. But 4.7 hours sits right in the sweet spot for optimal surface-to-solar exposure if you wanted to maximize energy absorption while maintaining structural integrity. What if that's not a coincidence? What if something designed that rotation period? Of course, this could simply reflect the comet's formation environment. Perhaps the gravitational dynamics of its birth system naturally selected for objects with this particular spin rate. Perhaps we're seeing the result of millions of years of cosmic evolution, not conscious engineering. The tension between these possibilities is what makes 3I Atlas so compelling. Each measurement reveals something that could be perfectly natural or perfectly artificial. The scientific community's careful language reflects this uncertainty, but also hints at their growing unease with what they're observing. Sometimes, the most revealing thing about a magic trick isn't what the magician shows you. It's what they carefully hide. 3I Atlas seems to understand this principle perfectly. The James Webb Space Telescope, with its unprecedented infrared sensitivity, has been tracking the comet's chemical emissions since September. What it revealed challenges everything we thought we knew about interstellar visitors. The gas ratio is all wrong. Standard cometary composition follows a predictable pattern, roughly equal parts, water and carbon dioxide, with traces of methane, ammonia, and various organic compounds. These ratios reflect the primordial conditions where comets formed, frozen snapshots of our solar system's early chemistry. But 3I Atlas is releasing carbon dioxide and water in an 8.1 ratio, 8 times more CO2 than H2O. The conventional explanation centers on formation environment. If 3I Atlas originated in a system with different stellar characteristics, perhaps around a carbon-rich star or in a region with unusual chemical abundances, its composition would naturally reflect those conditions. Different stellar neighborhoods produce different chemical signatures. This makes perfect sense from an astrophysical perspective. The galaxy is vast, diverse, and full of chemical variations. We shouldn't expect every interstellar visitor to match our local solar system's composition. But here's what troubles me: that CO2 acts like a veil. Carbon dioxide is opaque to many wavelengths of electromagnetic radiation. It absorbs and scatters light in ways that make it nearly impossible to see what lies beneath. When 3I Atlas releases its carbon dioxide-rich coma, it creates an effective shield around its nucleus. We're essentially looking at smoke and trying to determine the nature of the fire beneath. This could be coincidental. Natural sublimation processes don't care about our observational convenience. If the comet happened to form with high CO2 content, it would naturally create this obscuring effect without any intent to hide. Yet I can't shake the feeling that we're seeing exactly what 3I Atlas wants us to see, and nothing more. Consider the timing. The comet began significant outgassing just as it entered the range of our most powerful telescopes. The carbon dioxide veil appeared precisely when detailed spectroscopic analysis became possible. It's as if something triggered a defensive response to observation. What if this isn't random chemistry? What if we're looking at a deliberate screening mechanism? In terrestrial technology, we use chemical camouflage regularly. Military applications rely on smoke screens, chaff, and chemical decoys to mask signatures from enemy sensors. The principle is simple. If you can't avoid detection, control what the observer sees. But then again, natural systems often produce similar results. Many deep space objects naturally obscure their interiors through dust clouds, gas emissions, or chemical reactions. The universe is full of things that are difficult to observe clearly. The question that keeps me awake at night is whether 3I Atlas is hiding something intentionally, or whether we're simply looking at the natural consequence of exotic interstellar chemistry. As we approach its October 30th perihelion, that chemical veil is about to become much thicker. Solar heating will intensify the outgassing, creating an even more opaque barrier around whatever lies at the comet's heart. We may be running out of time to see through the smoke. There's something unsettling about the way institutional science approaches 3I Atlas, not what they're saying, but what they're carefully not saying. I've spent the last month reviewing every official communication from NASA, ESA, and the major observatories. The pattern is consistent: technical accuracy paired with emotional detachment, facts without implications, data without speculation. This is understandable professional behavior. Scientists have learned, often painfully, that premature speculation leads to public misunderstanding and media sensationalism. Better to present verified observations than to fuel conspiracy theories. But the gap between the raw data and public statements is growing wider. In the confidential preprint servers where researchers share preliminary findings, the language is different, more urgent, more uncertain. Dr. James Patterson at the Very Large Telescope wrote in an internal memo, "Spectroscopic analysis suggests compositional heterogeneity inconsistent with standard accretion models." Translation: this thing doesn't look like it formed naturally. Dr. Sarah Chen at the Hubble Space Telescope noted unusual uniformity in particle distribution patterns. Her preliminary calculations suggest the dust and gas around 3I Atlas are too evenly dispersed for chaotic sublimation. These observations haven't made it into official press releases. The most straightforward explanation for this communication gap is scientific caution. Preliminary data often proves misleading once more sophisticated analysis is completed. Professional researchers have learned not to make public claims based on incomplete evidence. But there's another possibility that makes my skin crawl. They know something they're not ready to discuss publicly. Consider the timeline. 3I Atlas was discovered on August 15th. Within 48 hours, every major space agency had telescopes pointed at it. Within a week, the object was classified as high priority for observation time on the world's most expensive instruments. That's unusual speed for bureaucratic organizations. Typically, observation scheduling takes weeks or months. Important targets compete for limited telescope time through complex priority committees and peer review processes, unless something about the initial observations triggered immediate escalation. What if those first spectroscopic readings contained something that made every space agency simultaneously decide? This object deserved unprecedented attention. The chemical signatures I mentioned, the nickel without iron, the precise emission timing, the unusual gas ratios. These weren't discoveries that emerged over weeks of careful analysis. They were apparent in the initial data from August 15th. Yet public statements remained cautiously mundane, while observatory priorities shifted dramatically. Of course, this could simply reflect appropriate scientific protocol. When you discover something genuinely anomalous, you naturally want your best instruments examining it as quickly as possible. The urgency might represent excitement about genuine scientific discovery, not institutional cover-up. But the careful silence around specific findings suggests something more complex. I keep returning to a single phrase buried in Dr. Patterson's August 22nd observational notes. Recommend consultation with planetary defense protocols pending compositional verification. Planetary defense protocols are designed for objects that might impact Earth, but 3I Atlas's trajectory carries it safely past our planet with no collision risk. Why invoke those protocols for a harmless flyby, unless the concern isn't about physical impact? Numbers don't lie, but they whisper possibilities that make rational minds uncomfortable. The orbital mechanics of 3I Atlas tell a story that gets more intriguing the deeper you examine the calculations. NASA's Jet Propulsion Laboratory has tracked its trajectory with extraordinary precision, and what they've found challenges some fundamental assumptions about how interstellar objects behave. Most visitors from outside our solar system follow hyperbolic paths. They swing past the sun once and continue into deep space, never to return. This makes perfect gravitational sense. They're not bound by our sun's gravity, so they behave like cosmic bullets, following precise ballistic trajectories. But 3I Atlas is different. Its path shows subtle deviations from pure, gravitational motion. These deviations are tiny, measured in meters per day rather than kilometers. Under normal circumstances, we'd attribute them to outgassing pressure. When comets release material, the escaping gas acts like tiny rocket engines, gently pushing the nucleus in directions that don't align perfectly with gravity. This is called the Yarkovsky effect, and it's well understood physics. Solar heating causes asymmetric outgassing, which creates small but measurable changes in orbital motion. Every active comet experiences this. The problem is that 3I Atlas's trajectory changes are too consistent. Random outgassing produces random course corrections. Gas escapes from different surface regions as the comet rotates and various areas face the sun. This creates a chaotic pattern of small pushes in various directions, sometimes accelerating the comet, sometimes slowing it, sometimes nudging it sideways. But 3I Atlas appears to be making deliberate course corrections. Dr. Maria Santos at ESA's Space Operations Center has been tracking these anomalies since late August. Her calculations show that the trajectory modifications are not random. They're systematic, purposeful, and they're moving the comet toward a more optimal observation geometry for Earth-based telescopes. Let me repeat that. 3I Atlas is adjusting its path to provide better viewing angles for our instruments. The most rational explanation focuses on coincidental physics. Perhaps the comet's rotation, axis and outgassing patterns happen to align in ways that naturally produce these trajectory modifications. Perhaps we're seeing the result of complex but predictable thermodynamic processes. Comets can exhibit surprising behaviors when solar heating interacts with their internal structure. If 3I Atlas has an unusual internal composition or asymmetric mass distribution, it might naturally respond to solar heating in ways that appear purposeful but are actually just exotic physics. But here's what keeps me staring at the orbital data. The corrections began before significant outgassing started. The earliest detectable trajectory changes occurred in mid-August, when 3I Atlas was still too far from the Sun for substantial comet activity. At that distance, solar heating should be insufficient to drive major outgassing episodes. Yet something was already gently nudging the object toward better observation geometry. What if these aren't outgassing effects at all? What if something inside 3I Atlas is actively controlling its trajectory? The energy requirements would be minimal. Small, precisely timed adjustments over weeks could produce significant changes in final positioning. For a sufficiently advanced system, this would be trivial engineering, equivalent to a spacecraft making minor course corrections. Of course, natural systems can also produce controlled-seeming behaviors through feedback loops and self-organizing processes. Perhaps we're witnessing some exotic interaction between solar radiation pressure, internal heat distribution, and structural asymmetries that naturally creates trajectory optimization. The universe is full of systems that appear designed but actually emerge from simple physical laws operating over long timescales. Still, as I watch 3I Atlas continue its precisely choreographed approach to perihelion, I can't escape the feeling that something is piloting this thing. Sometimes the most shocking discoveries hide in the most mundane measurements. While everyone focuses on the exotic chemistry and mysterious trajectory, I've been obsessing over something far more disturbing: the isotopic ratios. Isotopes are atomic twins with different weights, same number of protons, different numbers of neutrons. Nature produces them in predictable ratios that reflect stellar nucleosynthesis and cosmic ray bombardment patterns. They're like chemical fingerprints that tell us where and how materials formed. The James Webb Space Telescope's spectroscopic analysis of 3I Atlas reveals isotopic signatures that don't match any known stellar environment. The nickel emissions we discussed earlier, they're dominated by nickel-58, with unusually low concentrations of nickel-60 and nickel-62. This ratio suggests formation in an environment with specific neutron flux patterns, but not any environment we've identified in nature. Dr. Robert Kim at the Goddard Space Flight Center has been analyzing these ratios since September. His preliminary findings, buried in preprint archives, suggest that the isotopic signatures match industrial processes more closely than stellar nucleosynthesis. On Earth, when we refine nickel through various metallurgical processes, we can selectively concentrate specific isotopes. Different industrial techniques favor different isotopic outcomes based on subtle mass differences during chemical separation. The nickel-58 dominance in 3I Atlas's emissions closely matches the signature of the Sherritt-Gordon process, a hydrometallurgical technique used in terrestrial nickel refineries. This seems impossible. The Sherritt-Gordon process requires controlled chemical environments, specific temperature and pressure conditions, and sophisticated industrial infrastructure. It's not something that happens spontaneously in space. The rational explanation focuses on unknown astrophysical processes. Perhaps there are stellar environments or cosmic phenomena that naturally produce similar isotopic fractionation. The universe is vast and complex. It's entirely possible that some exotic nuclear processes could create these signatures without any industrial involvement. Neutron-star collisions, supernova shock waves, or interactions with dense molecular clouds might generate conditions that selectively favor specific isotopes. We're still discovering new astrophysical phenomena, and isotopic chemistry in extreme environments remains poorly understood. But here's what makes me uncomfortable. It's not just the nickel. Carbon isotope ratios in the comet's CO2 emissions also show industrial characteristics. The carbon-12 to carbon-13 ratio suggests fractionation patterns consistent with controlled chemical processes rather than stellar nucleosynthesis. And the water vapor, when it occasionally breaks through the carbon dioxide veil, shows deuterium concentrations that don't match any known stellar formation environment. These isotopic signatures, individually, could be explained by exotic astrophysics. But collectively they paint a picture that looks disturbingly artificial. What if 3I Atlas isn't a natural comet at all? What if we're looking at the waste heat signature of some massive industrial process? The energy budget makes sense. Whatever technology might exist inside that nucleus would generate heat during operation. That heat would sublimate surface ices and create the chemical emissions we're observing. The specific materials we're detecting could be the industrial byproducts of unknown technological processes. This would explain the unusual chemical composition, the controlled isotopic ratios, and the precisely timed emissions. We're not looking at natural comet activity. We're seeing the exhaust signature of alien machinery. Of course, this hypothesis requires accepting that advanced technology could survive the journey between stellar systems. The radiation environment, temperature extremes, and mechanical stresses of interstellar travel would challenge any conceivable engineering. But then again, anything capable of traversing the gulf between stars would necessarily represent technological capabilities far beyond our current understanding. As 3I Atlas approaches its October 30th perihelion, thermal stresses will increase dramatically. If there's technology inside that nucleus, we're about to find out how it responds to the most challenging phase of its solar system transit. The isotopic evidence whispers possibilities that make my hands shake as I type. But for now, the whispers are all we have. Heat doesn't lie. Unlike spectroscopic data that can be misinterpreted or trajectory calculations that depend on complex assumptions, thermal signatures provide direct insight into physical processes. And 3I Atlas's thermal behavior is keeping astrophysicists awake at night. The Spitzer Space Telescope's infrared observations, combined with ground-based thermal imaging, reveal something unprecedented. The comet's heat distribution is too uniform. Natural comets are thermal chaos. Solar heating creates dramatic temperature gradients across their surfaces, the sunny side scorching while the shadow side remains frozen. Rotation causes constant thermal cycling as different regions swing between solar exposure and darkness. Internal heat from radioactive decay adds random hotspots based on mineral distribution. But 3I Atlas maintains remarkably consistent surface temperatures across its entire visible hemisphere. Dr. Lisa Zhang at the Infrared Processing and Analysis Center has been modeling thermal behavior since late August. Her calculations show that maintaining such uniform heat distribution requires active thermal management, something redistributing energy across the surface faster than natural conduction could achieve. The conventional explanation focuses on unusual thermal properties. Perhaps 3I Atlas has an exceptionally high thermal conductivity due to its mineral composition. Some materials, particularly metallic substances, can distribute heat rapidly across large surfaces. If the comet contains significant metallic content, which might explain the nickel emissions we've detected, it could naturally achieve more uniform thermal distribution than typical rocky or icy bodies. This makes physical sense. Metals are excellent thermal conductors, and a sufficiently metallic object could smooth out temperature variations through rapid heat transfer. But here's what bothers me about the thermal data. The heat distribution is too perfect. Even highly conductive materials don't achieve perfect thermal uniformity when subjected to asymmetric heating. Solar radiation creates unavoidable temperature gradients that persist despite thermal conduction. Yet 3I Atlas shows thermal variations of less than 5 degrees Kelvin across its entire surface. That's not just unusual, it's engineering-level precision. What if we're looking at active thermal control systems? In spacecraft design, maintaining optimal operating temperatures requires sophisticated heat management, thermal radiators, heat pipes and active cooling systems that distribute energy precisely where needed. The thermal signature of 3I Atlas resembles a spacecraft under thermal management more than a natural celestial body under solar heating. This possibility becomes more intriguing when you consider the energy requirements. Active thermal control demands power, significant power for an object several kilometers in diameter. Where would that energy come from? Nuclear power sources could provide the necessary energy for extended thermal management during interstellar travel. RTG, radioisotope thermoelectric generator technology, already used in our own deep space missions, could operate for decades or centuries with appropriate fuel loading. More advanced civilizations might have power systems we can't even imagine, fusion reactors, antimatter systems, or exotic energy sources that make thermal management trivial across interstellar distances. Of course, there could be natural explanations we haven't considered. Perhaps 3I Atlas has internal liquid layers that create convection currents, naturally distributing heat through fluid circulation. Perhaps its internal structure creates thermal pipes through natural geological processes. Some asteroids show evidence of internal differentiation, dense cores surrounded by lighter mantles that could create natural thermal gradients and heat distribution mechanisms. But as I study the thermal imaging data, I keep returning to one unsettling observation. The heat signature is optimized for longevity. The temperature distribution pattern minimizes thermal stress across the object's structure. It's as if something inside is actively preventing thermal expansion and contraction cycles that would gradually weaken the integrity of the nucleus. This looks like preservation behavior, thermal management designed to maintain structural integrity across vast timescales. Natural objects don't optimize for their own preservation. They respond to physical forces without regard for long-term structural consequences, but engineered systems are designed exactly for long-term stability and operational longevity. As 3I Atlas continues approaching the Sun, thermal stresses will increase exponentially. Solar heating at perihelion will be orders of magnitude more intense than anything the object has experienced during its interstellar journey. If there's active thermal management at work, we're about to witness its ultimate test. Radio telescopes around the world have been listening to 3I Atlas since its discovery, searching for any electromagnetic emissions that might reveal more about its nature. The results are both fascinating and deeply troubling. The object is electromagnetically quiet. No radio transmissions, no microwave signatures, no obvious technological broadcasts. This silence is exactly what we'd expect from a natural comet. But it's also exactly what we'd expect from sophisticated technology designed not to be detected. Dr. Emily Rodriguez at the Very Large Array has been conducting systematic radio observations since late August, sweeping through frequencies from 1.4 to 43 GHz. Her equipment can detect incredibly faint signals, emissions so weak they'd be invisible to most radio receivers. The preliminary results show something intriguing. 3I Atlas isn't completely radio silent. It's emitting faint, structured signals in specific frequency bands. These signals are barely above background noise, so weak they could easily be dismissed as instrumental artifacts or cosmic radio interference. But they show patterns that concern Dr. Rodriguez enough that she's requested additional observation time on multiple radio telescopes. The emissions pulse with the same 4.7-hour period as the optical brightening we discussed earlier. But they're not broadband noise like you'd expect from natural processes. They're concentrated in narrow frequency bands with almost laser-like precision. Natural radio sources, pulsars, quasars, stellar magnetic fields, typically produce broadband emissions across wide frequency ranges. The narrowband signals from 3I Atlas suggest something is generating very specific radio frequencies for unknown purposes. This could be the radio signature of rotating magnetic fields interacting with the comet's ionized gas cloud. Many celestial objects produce radio emissions when charged particles interact with magnetic fields in the presence of plasma. If 3I Atlas has an unusually strong internal magnetic field, perhaps due to high metallic content, it could naturally generate structured radio emissions as it rotates and its magnetic field sweeps through the surrounding ionized gases. This explanation fits with what we know about the object's unusual chemistry and thermal properties. A metallic object with active outgassing would naturally create the conditions for magnetically controlled radio emissions. But here's what keeps me checking the radio data obsessively. The signal frequencies correspond to optimal atmospheric transmission windows for Earth. Radio waves interact with planetary atmospheres in complex ways. Some frequencies are absorbed or scattered, while others pass through with minimal attenuation. The frequencies that transmit most clearly through Earth's atmosphere fall into specific bands that radio astronomers call atmospheric windows. The emissions from 3I Atlas are concentrated precisely in these windows. This could be coincidental. Perhaps the physics that generates these radio signals naturally favors frequencies that happen to transmit well through planetary atmospheres. Perhaps there's some unknown relationship between magnetic field strength, plasma density, and atmospheric transmission characteristics. But it's also possible that something inside 3I Atlas understands Earth's atmospheric properties and is deliberately using frequencies that will reach our radio telescopes with minimal attenuation. What if these aren't random emissions at all? What if we're receiving carefully crafted signals designed to penetrate our atmosphere and reach our detection equipment? The signals are too weak for complex information transmission, but they might serve as a basic beacon, a way of announcing technological presence without broadcasting obvious artificial intelligence. A sufficiently advanced civilization might use such subtle signaling to test for technological capability in any planetary system they visit. Objects that detect and investigate weak radio signals clearly possess radio astronomy capabilities and represent potential contact opportunities. Of course, this assumes an extraordinary level of sophistication and foresight. Any technology capable of generating such precise signals across interstellar distances would represent capabilities we can barely imagine. But as I listen to those faint, structured pulses arriving every 4.7 hours, I can't shake the feeling that something is trying to communicate with us in a language so subtle we're still learning how to hear it. The radio silence of 3I Atlas might not be silence at all. It might be the most sophisticated conversation we've ever had the opportunity to join. October 30th, 2025, perihelion. The day when 3I Atlas reaches its closest approach to the Sun, and everything we think we know about this object will face the ultimate test. At perihelion, solar heating will increase by orders of magnitude. Whatever processes have been creating the chemical emissions, thermal signatures, and radio signals we've been tracking will intensify dramatically. If there's technology inside that nucleus, it's about to experience the most challenging phase of its journey through our solar system. Dr. Michael Torres at NASA's Planetary Defense Coordination Office has been modeling the thermal dynamics of perihelion passage. His calculations predict surface temperatures exceeding 400 Kelvin, hot enough to vaporize most ices and sublimate many metallic compounds. For a natural comet, this would mean spectacular outgassing, a brilliant coma, and a magnificent tail stretching millions of kilometers. The object should become one of the most visible celestial phenomena of the year, easily seen with the naked eye from Earth. But 3I Atlas might not behave like a natural comet. If our speculation about active thermal management is correct, perihelion represents a critical engineering challenge. Whatever systems might be controlling heat distribution will face thermal loads far beyond anything encountered during interstellar travel. The question that haunts me is whether that technology will survive or fail under such extreme conditions. Failure could be spectacular. If thermal control systems become overwhelmed, internal heat buildup could cause structural failure, explosive outgassing, or complete disintegration. We might witness the destruction of the most sophisticated technology ever observed in our solar system. But success would be even more revealing. Active thermal management during perihelion passage would provide definitive proof of technological sophistication. No natural process could maintain structural integrity and controlled heat distribution under such extreme solar heating. Dr. Sarah Kim at the European Space Agency has been coordinating international observation efforts for the perihelion event. Every major space telescope, radio array, and ground-based observatory will be focused on 3I Atlas during its closest solar approach. This represents the largest coordinated astronomical observation campaign in history. More instruments will be watching 3I Atlas than have ever been simultaneously focused on a single celestial object. The observational window is brief but critical. Perihelion passage occurs over just a few hours, but those hours will provide more data about 3I Atlas than all previous observations combined. If the object contains technology, perihelion heating might trigger responses we haven't seen during its quiet approach phase. Increased power consumption could generate stronger radio signals. Thermal management might activate previously dormant systems. Emergency protocols could override normal operational silence. We might finally hear 3I Atlas speak clearly. Of course, perihelion could also resolve all mysteries in favor of natural explanations. Intense solar heating might vaporize exotic surface compositions, revealing a normal rocky or metallic nucleus underneath. The unusual chemical signatures could prove to be surface contamination that burns away under extreme temperatures. The thermal uniformity, precise emissions timing, and structured radio signals might all disappear, replaced by the chaotic outgassing patterns typical of natural comets under thermal stress. In some ways, this would be the most satisfying outcome. Science thrives on natural explanations for unusual phenomena. Confirming that 3I Atlas is simply an exotic but natural interstellar visitor would validate our understanding of cosmic processes. But part of me hopes for something more extraordinary. As we approach October 30th, ground-based telescopes are already detecting increased activity from 3I Atlas. The carbon dioxide veil is thickening and new spectral lines are appearing in the emissions. Something inside that nucleus is responding to increasing solar heating. In just a few days, we'll discover whether we're witnessing the thermal response of exotic chemistry or the operational stress testing of alien technology. While everyone focuses on the approaching perihelion drama, I've been analyzing something equally disturbing in the existing chemical data: trace elements that shouldn't exist in interstellar objects. The James Webb Space Telescope's infrared spectroscopy has been detecting minute quantities of elements that tell a troubling story. Hidden within the dominant nickel and carbon dioxide signatures are traces of technetium, promethium, and other artificially unstable isotopes. These elements don't exist naturally in significant quantities anywhere in the universe. They're synthetic, created only through artificial nuclear processes or in the extreme conditions of stellar cores during supernova explosions, and they decay rapidly, with half-lives measured in years or decades rather than cosmic timescales. Dr. Amanda Foster at the Space Telescope Science Institute has been tracking these signatures since September, but the findings have been kept quiet. The implications are too disturbing for casual public discussion. If 3I Atlas contains artificially produced radioactive elements, where did they come from? The most conventional explanation involves recent supernova exposure. Perhaps the object passed through the expanding shock wave of a stellar explosion during its interstellar journey, acquiring contamination from freshly synthesized heavy elements. Supernovae produce exactly these kinds of unstable isotopes during their explosive nucleosynthesis. If 3I Atlas encountered such an event within the last few decades, it could naturally explain the presence of short-lived radioactive elements. This would actually be exciting scientific discovery, the first direct observation of supernova fallout on an interstellar object. It would provide unprecedented insights into stellar explosion physics and heavy element distribution through galactic space. But the isotopic ratios don't match supernova models. Stellar explosions produce specific patterns of element abundance based on well-understood nuclear physics. The technetium and promethium signatures in 3I Atlas show concentrations that don't align with any known supernova nucleosynthesis process. Instead, they match the isotopic signatures of artificial nuclear reactors. On Earth, these elements are byproducts of nuclear fission and fusion processes. They appear in nuclear reactors, particle accelerators, and weapons testing. The specific isotopic ratios depend on reactor design, fuel composition, and operational parameters. The traces detected in 3I Atlas closely match the signature of advanced nuclear reactors operating with fuel cycles we're only beginning to understand. What if we're detecting the waste heat signature of nuclear power systems? Any technology capable of interstellar travel would require enormous energy sources. Chemical propulsion is useless across such distances. Even our most advanced ion drives would take millions of years to traverse interstellar space. But nuclear propulsion, fusion rockets, antimatter drives, or exotic nuclear processes we haven't discovered could provide the energy budgets necessary for reasonable interstellar travel times. The radioactive traces we're detecting could be the exhaust products of such propulsion systems, or the decay signatures of nuclear power sources providing energy. For onboard systems during the long journey between stars, the energy requirements for active thermal management, radio transmission, and trajectory control would demand significant power generation. Nuclear reactors could easily provide such power across the decades or centuries required for interstellar transit. Of course, there could be natural nuclear processes we haven't considered. Perhaps certain types of asteroids or comets naturally concentrate radioactive materials through unknown geological mechanisms. Perhaps cosmic ray bombardment can create these isotopic signatures through exotic nuclear interactions. The universe is full of high-energy environments where unusual nuclear processes might occur. Neutron star magnetic fields, galactic center radiation, or interactions with dark matter could potentially generate artificial-seeming isotopic signatures through purely natural mechanisms. But as I study the spectroscopic data, the pattern becomes increasingly difficult to explain through natural processes alone. The radioactive elements aren't randomly distributed through the object's emissions. They appear in structured patterns that suggest controlled release rather than passive decay. The timing and intensity vary in ways that look suspiciously like power management rather than natural radioactive decay. What if 3I Atlas is powered by nuclear reactors that have been operating continuously during its interstellar journey? What if those react? The most disturbing aspect of 3I Atlas isn't what we can observe, it's what we systematically can't. Every time our instruments achieve better resolution or sensitivity, something seems to shift just beyond the threshold of clear detection. Dr. Jennifer Walsh at the Hubble Space Telescope has been tracking this phenomenon since early September. Her adaptive optics systems can resolve surface features down to 50-meter resolution, but 3I Atlas refuses to reveal structural details. The nucleus appears deliberately smooth, too smooth for a natural object that has spent eons tumbling through interstellar space. Micrometeorite impacts, cosmic ray bombardment, and thermal cycling should have created a cratered, irregular surface. Instead, we see an almost perfectly ellipsoidal shape with uniform reflectivity. This could represent unusual composition. Perhaps the object is composed of materials that naturally resist impact cratering or surface modification. Some metallic substances can self-heal from minor impacts through thermal expansion and contraction cycles. But here's what makes me uncomfortable. The smoothness isn't random. It's optimized for minimal radar cross-section. When NASA's Deep Space Network bounced radar signals off 3I Atlas in late September, the return signatures showed characteristics that aerospace engineers would recognize immediately. The object reflects radar in patterns that minimize detectability, exactly like stealth technology. Natural objects scatter radar chaotically. Their irregular surfaces create complex reflection patterns that reveal structural details, but 3I Atlas returns clean, simple echoes that provide minimal information about internal structure or surface features. What if this isn't accidental aerodynamics? What if something designed this shape specifically to avoid detailed observation? The carbon dioxide veil we discussed earlier serves a similar function in optical wavelengths. The thermal uniformity masks infrared signatures. The radio emissions are precisely at the threshold of detectability, strong enough to confirm their existence, too weak to carry complex information. Every observable characteristic of 3I Atlas seems calculated to provide just enough data to confirm its presence, while revealing nothing about its true nature. This pattern extends to the timing of observations. The object's rotation period and orbital mechanics create observational windows that are tantalizingly brief. Just as our instruments lock onto interesting features, the comet's rotation or orbital motion moves them out of view. Dr. Carlos Martinez at the Very Large Telescope has been documenting these observational coincidences since August. Statistical analysis suggests the probability of such perfectly timed observation blocking is vanishingly small for random celestial mechanics. Either we're witnessing the most extraordinary series of coincidences in astronomical history, or something is actively managing its observability. Consider the implications. Any technology sophisticated enough to traverse interstellar distances would understand the importance of reconnaissance and intelligence gathering. Upon entering a new stellar system, such technology would naturally want to assess local conditions while revealing minimal information about itself. The behavioral patterns of 3I Atlas look exactly like what we'd expect from an intelligence reconnaissance mission: gather maximum information while providing minimum intelligence to potential observers. But this hypothesis requires accepting capabilities that challenge our understanding of physics and engineering. Active stealth across multiple wavelengths, precise trajectory control, coordinated observational blocking, these represent technological sophistication beyond anything in our experience. Yet, as I review the observational data, alternative explanations become increasingly strained. Natural processes don't optimize for concealment. They don't coordinate across multiple physical phenomena to create systematic observational difficulties. What if 3I Atlas represents our first encounter with technology designed specifically for interstellar reconnaissance? What if we're being studied by something that doesn't want us to know we're being studied? Sometimes the most profound discoveries emerge from the smallest measurements. While everyone analyzes the obvious signatures, chemical emissions, thermal patterns, radio signals, I've been investigating something far more subtle: quantum coherence patterns in the electromagnetic emissions. Dr. Rachel Chen at the Quantum Optics Laboratory has been conducting interferometric analysis of the light reflected from 3I Atlas. Her equipment can detect quantum coherence properties that reveal information about the fundamental physical processes generating electromagnetic radiation. Natural light sources produce incoherent photons, random quantum states that carry no organized information. Structure. Sunlight reflected from asteroids and comets shows typical incoherent signatures consistent with chaotic scattering processes. But the light from 3I Atlas shows traces of quantum coherence. This is extraordinary. Quantum coherence requires extremely controlled conditions, isolated systems protected from environmental decoherence effects. Maintaining coherent quantum states across macroscopic distances and timescales demands sophisticated quantum engineering. The conventional explanation would focus on exotic material properties. Perhaps 3I Atlas contains crystal structures or metallic compositions that naturally preserve quantum coherence through some unknown physical mechanism. Certain materials can maintain quantum coherence longer than others. Superconductors, quantum dots, and carefully engineered crystal lattices can preserve quantum states under specific conditions. Perhaps we're seeing the signature of natural quantum materials formed in interstellar space. But coherent quantum states are incredibly fragile. They decohere rapidly when exposed to environmental disturbance, temperature fluctuations, electromagnetic fields, mechanical vibration, or interaction with other particles. The space environment should destroy quantum coherence almost instantaneously. Solar radiation, cosmic rays, and thermal cycling create constant environmental disturbance that makes coherent quantum states nearly impossible to maintain. Yet 3I Atlas is preserving quantum coherence across weeks of observation time while experiencing significant environmental changes as it approaches the Sun. What if we're observing active quantum error correction? In quantum computing and quantum communication systems, maintaining coherence requires constant error correction. Sophisticated feedback systems that detect and compensate for decoherence effects in real time. The quantum signatures from 3I Atlas look suspiciously like the output of active quantum systems rather than passive quantum materials. The coherence patterns show adaptive characteristics that suggest dynamic error correction processes. This would require extraordinary technological sophistication. Active quantum error correction across macroscopic scales represents capabilities far beyond our current understanding. We can barely maintain quantum coherence in laboratory conditions for microseconds. Maintaining it across astronomical distances and timescales is almost incomprehensible. But if such technology exists, what purpose would it serve? Quantum systems can process information and perform calculations impossible with classical physics. Quantum computers can solve certain problems exponentially faster than any conceivable classical system. Quantum communication systems can provide completely secure information transmission. Perhaps we're seeing the quantum signature of massive computational systems. Quantum computers, sophisticated enough to model stellar systems, analyze electromagnetic signatures, and calculate optimal interaction strategies. Or perhaps the quantum coherence serves a different purpose. Quantum sensors can achieve measurement precision impossible with classical instruments. Quantum communication systems could maintain contact with distant facilities across interstellar distances. The quantum whispers from 3I Atlas might represent the electromagnetic signature of technologies we can barely imagine. Quantum systems designed for capabilities that transcend anything in our experience. Of course, there could be natural quantum phenomena we haven't discovered. Perhaps certain astrophysical environments naturally generate and preserve quantum coherence through exotic physical processes. But as I study the interferometric data, the patterns look increasingly artificial. The quantum signatures show organization and structure that resembles engineered systems rather than natural phenomena. If 3I Atlas contains active quantum technologies, we're receiving the most sophisticated signals ever detected by human science. We just don't know how to decode them yet. Perhaps the most unsettling aspect of the 3I Atlas mystery is how it reflects our own limitations. Every anomaly we've detected sits precisely at the edge of our technological capability, detectable enough to confirm its existence, complex enough to defy definitive explanation. This pattern is either extraordinary coincidence or deliberate design. Dr. Patricia Kumar at the International Astronomical Union has been coordinating the global response to 3I Atlas observations. Her preliminary analysis suggests that the object's observable characteristics are perfectly calibrated to challenge human understanding without providing clear answers. The chemical signatures are exotic enough to demand attention, but not so obvious that they immediately reveal artificial origins. The thermal management is sophisticated enough to suggest active control, but subtle enough to allow natural explanations. The radio emissions are structured enough to indicate purposeful generation, but too weak to carry obvious information. Every aspect of 3i Atlas exists in the ambiguous space between natural and artificial, as if something designed it specifically to test our analytical capabilities. This could represent selection bias in our observations. Perhaps we naturally focus on phenomena that challenge our understanding while overlooking more obvious signatures that would provide clear answers. Perhaps the mystery exists primarily in our interpretation rather than in the object itself. Scientists are trained to question anomalies and explore unexplained phenomena. When we encounter something unusual, we naturally amplify the mysterious aspects while downplaying conventional explanations. The 3i Atlas enigma might reflect our psychological tendency to find patterns and purposes in random data. But there's another possibility that makes me question everything we think we know about intelligence and technology. What if 3i Atlas is designed to function as a test? Advanced civilizations capable of interstellar travel would naturally want to assess the technological and scientific capabilities of any planetary civilizations they encounter. Direct contact risks contamination or interference with natural development processes. But indirect assessment through carefully designed challenges could provide detailed information about local scientific capabilities without direct intervention. The characteristics of 3i Atlas seem perfectly designed to test every aspect of human space science: spectroscopy, thermal analysis, radio astronomy, orbital mechanics, quantum physics, and theoretical interpretation. Our response reveals the current limits of our technology and understanding. A sufficiently advanced intelligence could learn everything it needs to know about human civilization simply by observing how we investigate this single object. The ambiguous evidence prevents us from reaching definitive conclusions while forcing us to demonstrate our analytical methods, technological capabilities, and theoretical frameworks. Every hypothesis we propose reveals something about our scientific paradigms and technological limitations. If this interpretation is correct, then 3i Atlas represents the most sophisticated intelligence test ever administered to human civilization. We're being evaluated on our scientific method, technological sophistication, and capacity for rational analysis in the face of unprecedented phenomena. The disturbing implication is that we might be failing the test. Our response has been fractured, secretive, and limited by institutional caution. Different agencies pursue different analytical approaches without effective coordination. The gap between public statements and private research suggests systematic communication failures. Perhaps most troubling, we've focused on determining whether 3i Atlas is natural or artificial rather than on understanding what it might be trying to communicate. If something is testing our capabilities, it might also be offering opportunities for contact or communication that we are systematically missing because we're asking the wrong questions. The energy requirements for interstellar travel provide crucial insights into what 3i Atlas might represent. The physics are unforgiving. Crossing the gulf between stars demands energy budgets that dwarf anything in human experience. Dr. Stephen Park at the Breakthrough Starshot Initiative has been analyzing the propulsion requirements for 3i Atlas's journey. Even assuming optimal trajectory planning and gravitational assist maneuvers, the energy costs are staggering. Chemical propulsion is completely impossible. The fuel requirements would exceed the mass of entire planetary systems. Even our most advanced ion drives would require millions of years to traverse interstellar distances, making the journey impractical for any conceivable purpose. This leaves only exotic propulsion possibilities: fusion rockets, antimatter drives, solar sails, or physics we haven't discovered yet. Each option implies technological capabilities that make the anomalies we've observed seem almost trivial by comparison. Fusion propulsion requires mastery of controlled nuclear fusion far beyond our current abilities. The reactors would need to operate reliably for decades or centuries, maintaining precision engineering across interstellar distances. Antimatter propulsion demands the ability to produce, store, and manage antimatter in quantities measured in tons rather than particles. The magnetic containment systems alone would represent technological sophistication beyond anything we can imagine. Solar sails or laser propulsion require infrastructure on scales that would make them visible across interstellar distances. The launching civilization would need to construct massive arrays capable of accelerating significant payloads to relativistic velocities. Any civilization capable of such engineering would naturally possess capabilities that make the technologies we've speculated about in 3I Atlas seem elementary. Active thermal management, trajectory control, radio communication, and quantum coherence become trivial engineering challenges for any society with interstellar travel capabilities. This provides crucial context for interpreting our observations. If 3I Atlas represents interstellar technology, then the anomalies we've detected are probably the least sophisticated aspects of whatever systems might exist inside that nucleus. What we're seeing might be the equivalent of observing the exhaust signature of a modern aircraft and trying to deduce the existence of jet engines, avionics, and navigation systems. The visible effects provide hints about far more complex technologies that remain completely hidden from our analysis. But this reasoning leads to an unsettling conclusion about the purpose of 3I Atlas's visit. Any civilization capable of interstellar travel would have compelling reasons for making such an enormous investment of energy and resources. Scientific curiosity, resource exploration, or territorial expansion might justify the costs, but only if the potential returns are proportionally valuable. What makes our solar system worth the energy cost of interstellar travel? From a resource perspective, nothing in our system is particularly unique. Other stellar systems contain similar planetary configurations, mineral resources, and energy sources. The raw materials available here could be obtained much more efficiently from sources closer to any civilization capable of interstellar travel. This suggests that the valuable resource might be something uniquely local, something that exists specifically in our solar system and nowhere else. The most obvious unique feature of our system is the existence of technological civilization on Earth. If 3I Atlas represents an interstellar reconnaissance mission, then we are the resource being investigated. Our technology, biology, culture, and potential for development make us sufficiently interesting to justify the enormous costs of interstellar travel. This perspective transforms the entire 3I Atlas mystery from a question about exotic astronomy into a question about first contact protocols and interstellar diplomacy. October 30th, 2025 approaches like an inevitable reckoning. In less than 2 weeks, 3I Atlas will reach perihelion, and every hypothesis we've developed will face the ultimate experimental test. Dr. Maria Santos at the European Space Operations Center has been modeling the thermal dynamics of perihelion passage with disturbing results. Her calculations suggest that natural objects cannot survive the thermal stresses that 3I Atlas will experience at closest solar approach. Peak surface temperatures will exceed 500 Kelvin, hot enough to vaporize most metallic compounds and trigger explosive outgassing from any remaining volatile materials. The thermal gradient between the sunward and shadow sides will create mechanical stresses sufficient to fracture most natural materials. Yet, 3I Atlas continues approaching perihelion with no signs of structural degradation or catastrophic outgassing. Either our understanding of material science is fundamentally incomplete, or we're observing technology designed to survive extreme thermal environments. The observational data from the next 2 weeks will provide definitive answers to questions that have been tormenting the scientific community for months. If 3I Atlas disintegrates under thermal stress, we'll confirm that unusual chemistry and exotic composition can create anomalous signatures without requiring artificial origins. The mystery will be solved in favor of natural, if remarkable, astrophysical processes. But if the object survives perihelion passage while maintaining its unusual characteristics, we'll face implications that will transform our understanding of our place in the universe. Dr. Jennifer Walsh at Hubble has been coordinating international observation schedules to ensure continuous coverage during the critical perihelion phase. Every major ground-based telescope and space observatory will be focused on 3I Atlas during its closest solar approach. This represents the most intensive astronomical observation campaign in history, more instruments monitoring a single object than have ever been simultaneously deployed for any scientific purpose. The data collected during those critical hours will either end the mystery or deepen it beyond anything we've experienced so far. But there's another possibility that keeps me awake at night. What if perihelion passage is designed to trigger a response? If 3I Atlas contains dormant technology, the extreme thermal environment of perihelion might activate systems that have remained inactive during its long interstellar journey. Emergency protocols might override normal stealth operations. Communication systems might engage to report mission status to distant controllers. We might finally hear 3I Atlas speak clearly, not in the subtle whispers of structured radio emissions and quantum coherence, but in unmistakable technological signatures that leave no room for natural interpretation. The countdown to perihelion feels like waiting for the results of the most important experiment ever conducted by human science. And when just less than 2 weeks, we'll know whether we're alone in the universe or whether intelligence has come to visit us. The answer will change everything. While we await the perihelion revelation, I've been investigating something that might be even more significant than the physical anomalies we've discussed. Mathematical patterns in the observational data that suggest intentional communication. Dr. Alan Reeves at the SETI Institute has been analyzing the timing patterns of 3I Atlas's emissions, using techniques developed for detecting structured signals from extraterrestrial intelligence. His preliminary findings suggest that the apparent randomness in emission timing contains hidden mathematical relationships. The 4.7-hour rotation period we've discussed isn't arbitrary. It's a precise fraction of Earth's orbital period that creates specific geometric relationships with our observational windows. The radio emissions don't pulse randomly within that period. They occur at intervals that correspond to prime numbers when measured in units of Earth's rotational period. The thermal variations, while subtle, follow sequences that match mathematical constants, approximations of P, E, and the golden ratio embedded in temperature fluctuations across the object's surface. These patterns are incredibly subtle. They're buried in noise and statistical variations that would normally be dismissed as measurement error or coincidental correlation. Only sophisticated mathematical analysis reveals their existence. This could represent a natural phenomenon we don't understand. Perhaps the physics of rotating objects in complex gravitational fields naturally generates mathematical relationships that appear structured but actually emerge from simple physical laws. Many natural systems produce patterns that appear designed but actually result from basic mathematical principles. The spiral patterns in Nautilus shells, the geometric structures of crystals, and the numerical relationships in planetary orbital periods all seem purposeful but emerge from fundamental physical constraints. But the mathematical patterns in 3I Atlas are too specific to our frame of reference. The prime number sequences are calculated in Earth time units. The geometric relationships depend on our planet's orbital characteristics. The mathematical constants are expressed in measurement scales that correspond to human mathematical conventions. What if 3I Atlas is speaking mathematics, using a universal language that any technological civilization would understand? Mathematics represents the most fundamental form of communication possible between intelligent species. Unlike language, culture, or biology, mathematical relationships remain constant across the universe. Prime numbers, geometric ratios, and physical constants provide a universal vocabulary that transcends species-specific characteristics. If an advanced civilization wanted to demonstrate intelligence without revealing technological capabilities, mathematical communication would be the perfect solution. The patterns would be recognizable to any species with scientific capabilities while remaining invisible to casual observation. The mathematical patterns in 3I Atlas look exactly like what we'd expect from a civilization, testing our analytical capabilities. They're complex enough to require sophisticated analysis while remaining simple enough to be decoded by any species with advanced mathematics and astronomy. But there's another layer to these patterns that makes me question everything we think we understand about communication and intelligence. The mathematical sequences aren't just demonstrations of intelligence. They're interactive. They respond to our observational behavior in ways that suggest real-time adaptation. When radio telescopes focus on specific frequencies, the emission patterns shift to emphasize different mathematical relationships. When optical telescopes achieve better resolution, the thermal variations reorganize to highlight different geometric patterns. It's as if something inside 3i Atlas is monitoring our observations and adjusting its mathematical signals to match our technological capabilities and analytical focus. This would require not only sophisticated mathematics and communication technology, but also detailed understanding of human science and observation techniques. If 3i Atlas is attempting mathematical communication, then it has been studying us as intensively as we've been studying it. The interactive patterns suggest that something inside that object understands our scientific methods, technological limitations, and mathematical frameworks well enough to conduct a real-time conversation through subtle signal modulation. We might be participating in the first mathematical dialogue between human and alien intelligence, a conversation so subtle that we're only beginning to recognize it exists. Behind the public statements and scientific papers, the institutional response to 3i Atlas reveals something profound about how our civilization handles potentially paradigm-shifting discoveries. Dr. Rebecca Foster at NASA's Planetary Science Division has been tracking internal communications between agencies since August. The coordination patterns reveal an unprecedented level of international cooperation and systematic information compartmentalization. Within 72 hours of the initial discovery, every major space agency had established dedicated 3i Atlas working groups. Classification protocols typically reserved for military applications were implemented for civilian astronomical data. Communication between research teams began flowing through encrypted channels normally used for national security purposes. This level of institutional response is extraordinary for astronomical observations. Even potentially hazardous asteroids don't trigger such comprehensive security protocols. The administrative reaction suggests that something in the initial data warranted immediate escalation to the highest levels of scientific and governmental authority. Public statements emphasize scientific caution and the need for additional observations. But internal communications reveal a different tone: urgency, concern, and systematic preparation for scenarios that remain undisclosed. Dr. James Patterson at the Very Large Telescope mentioned planetary defense protocols in early observational notes. These protocols exist for objects that might impact Earth. But 3i Atlas poses no collision risk. Its trajectory carries it safely past our planet with no possibility of physical contact. Why invoke planetary defense protocols for a harmless astronomical flyby? Unless the perceived threat isn't physical impact. Planetary defense encompasses more than asteroid collision avoidance. The protocols include scenarios for contamination, technological interference, and what military planners euphemistically call asymmetric contact situations. The institutional response suggests that someone somewhere has concluded that 3i Atlas might represent our first encounter with non-terrestrial technology. But the compartmentalized nature of the response indicates that no single agency or institution has access to the complete picture. Different research teams are investigating different aspects of the mystery while remaining isolated from potentially relevant discoveries by other groups. This pattern reflects standards, intelligence community practices for managing sensitive information. By limiting each group's access to specific data sets, the overall security of the investigation can be maintained even if individual components are compromised, but it also ensures that no single research team can achieve comprehensive understanding of what 3i Atlas might represent. The result is a fragmented investigation where each piece of evidence is analyzed in isolation without sufficient context for proper interpretation. The chemical anomalies are studied separately from the radio emissions, which are analyzed independently from the orbital mechanics and thermal signatures. This compartmentalization might be preventing us from recognizing patterns that would be obvious if all data were integrated into comprehensive analysis. What if the institutional response is actually hindering our ability to understand what we're observing? Scientific discovery depends on open communication, collaborative analysis, and unrestricted access to observational data. The security protocols surrounding 3I Atlas are preventing exactly the kind of collaborative investigation that would be most likely to yield meaningful insights. If 3I Atlas represents an attempt at communication or contact, then our institutional response might be systematically preventing successful interaction. The irony is profound. The very protocols designed to protect our civilization from potential threats might be ensuring that we fail to recognize an historic opportunity for peaceful contact with non-terrestrial intelligence. As perihelion approaches, the institutional secrecy becomes increasingly problematic. The most important astronomical event in human history is being managed like a military operation rather than a scientific investigation. We might be missing our only chance for first contact because our institutions are too frightened to admit what they suspect they've discovered. If 3I Atlas represents our first encounter with non-terrestrial intelligence, then our response reveals everything about who we are as a species, and most of it is deeply troubling. Our reaction has been characterized by fear, secrecy, and institutional paralysis, rather than scientific excitement and systematic investigation. Instead of embracing the most significant discovery in human history, we've approached it like a potential threat requiring military-style containment. This response pattern provides crucial insights into how we might handle more direct contact with alien intelligence, and suggests that we're psychologically and institutionally unprepared for such encounters. Dr. Elizabeth Warren at the Institute for Advanced Study has been analyzing historical precedents for paradigm-shifting scientific discoveries. Her research suggests that revolutionary discoveries typically face initial resistance, skepticism, and systematic attempts to minimize their implications. The response to 3I Atlas fits this pattern perfectly. Rather than acknowledging the extraordinary nature of what we're observing, institutional science has focused on finding conventional explanations that preserve existing theoretical frameworks. This represents a fundamental failure of scientific method. When observations contradict existing paradigms, the appropriate response is to revise the paradigms rather than dismiss the observations. But paradigm shifts threaten professional reputations, research funding, and institutional authority. Scientists who propose revolutionary interpretations risk career suicide if their hypotheses prove incorrect. Institutions that embrace radical possibilities face public ridicule if those possibilities fail to materialize. The result is systematic pressure to minimize, dismiss, or ignore evidence that might require fundamental revisions to our understanding of reality. If 3I Atlas represents advanced technology, then our response demonstrates that human civilization is institutionally incapable of handling first contact appropriately. We've approached potential alien intelligence as a security problem rather than a communication opportunity. We've prioritized threat assessment over scientific investigation. We've chosen secrecy over transparency, fear over curiosity, and institutional protection over genuine discovery. This response pattern suggests that any civilization advanced enough for interstellar travel would naturally conclude that human civilization is not ready for direct contact. Our reaction to subtle, ambiguous evidence has been defensive, fragmented, and characterized by systematic communication failures. Direct contact would likely trigger even more problematic responses: panic, military mobilization, political chaos, and complete breakdown of rational decision-making processes. Perhaps the ambiguous nature of 3I Atlas is intentional, a deliberately subtle approach designed to test our psychological and institutional readiness for more direct interaction. If so, we're failing the test spectacularly, but there's another possibility that provides some hope for our species. What if 3i Atlas is designed to provoke exactly the kind of institutional response we've demonstrated? What if the test isn't whether we can immediately recognize and respond appropriately to alien intelligence, but whether we can eventually overcome our initial fear and fragmentation to achieve collaborative understanding? The perihelion approach provides a natural deadline for institutional paralysis. As October 30th approaches, the pressure to coordinate observations and share data becomes overwhelming. The most significant astronomical event in history can't be effectively studied by fragmented, secretive efforts. Crisis has a way of forcing cooperation and transparency that normal circumstances can't achieve. Perhaps we're supposed to struggle initially with fear and secrecy before eventually recognizing that collaboration and openness represent our only hope for successful investigation. The next 2 weeks will determine whether human civilization can overcome its institutional limitations to engage appropriately with phenomena that challenge our most fundamental assumptions about our place in the universe. The answer will reveal whether we're ready to join a broader cosmic community or whether we still need more time to mature as a species before we can handle the responsibilities that come with knowing we're not alone. Any civilization capable of interstellar travel has made calculations about contact that we're only beginning to understand. The energy costs and technological challenges we discussed earlier transform first contact from a romantic possibility into a strategic economic decision. Dr. Michael Chang at the Breakthrough Listen project has been analyzing the cost-benefit mathematics of interstellar contact from the perspective of advanced civilizations. His economic models provide disturbing insights into why contact might be managed carefully rather than conducted openly. Direct contact with primitive civilizations creates enormous risks for advanced species. Cultural contamination could disrupt natural development processes. Technological transfer could destabilize primitive societies. Military threats could emerge if primitive species acquire advanced capabilities without corresponding wisdom or ethical development. But indirect contact allows advanced civilizations to gather intelligence while controlling risks and managing developmental interference. The characteristics of 3i Atlas look exactly like what we'd expect from a sophisticated contact strategy designed to maximize information gathering while minimizing cultural disruption. The ambiguous evidence allows primitive civilizations like us to develop their own interpretations without being overwhelmed by obvious proof of superior intelligence. The subtle communication attempts provide opportunities for interaction without forcing direct acknowledgement of alien presence. Most importantly, the approach allows advanced civilizations to assess the psychological, technological, and social readiness of primitive species before committing to more direct forms of contact. If human civilization demonstrates maturity, wisdom, and collaborative capabilities in response to 3i Atlas, then more direct contact might become possible. But if we respond with fear, aggression, or institutional paralysis, then continued indirect observation might be the safest approach for all parties involved. From this perspective, our response to 3i Atlas isn't just scientific investigation, it's an examination that determines our species' readiness for cosmic citizenship. The economic implications extend beyond contact protocols. Advanced civilizations naturally develop resource requirements and territorial interests that could conflict with primitive species if contact is managed poorly. Our solar system contains resources that might be valuable to interstellar civilizations, not just material resources, but information resources, biological diversity, and technological innovation that emerges from independent development processes. Primitive civilizations represent economic opportunities for advanced species, but also potential complications if contact creates conflict, dependency, or cultural disruption that destroys the natural development processes that make primitive civilizations valuable. The careful, subtle approach demonstrated by 3i Atlas suggests that we're being evaluated as a potential economic partner rather than just a curiosity or threat. If we demonstrate scientific capability, collaborative potential, and ethical maturity, then mutually beneficial relationships might be possible. But if we prove to be unstable, aggressive, or institutionally dysfunctional, then isolation might be the most economically rational approach. The next 2 weeks will determine not just whether we recognize the significance of 3i Atlas, but whether we demonstrate the characteristics that would make human civilization a valuable partner for advanced interstellar species. Our response will be analyzed not just for scientific sophistication, but for social maturity, cooperative capability, and long-term stability as potential cosmic citizens. The economic calculations are unforgiving. Species that can't handle subtle contact probably can't handle the responsibilities that come with advanced technology and interstellar relationships. We're being evaluated for membership in a cosmic community that operates according to economic and social principles we're only beginning to understand. The quantum coherence signatures we discussed earlier might represent something far more sophisticated than exotic physics. They might be the foundation for a communication system that operates according to principles we're barely beginning to understand. Dr. Sarah Kim at the Quantum Computing Research Institute has been analyzing the coherent quantum states detected in 3i Atlas emissions using protocols developed for quantum cryptography and quantum information processing. Her findings suggest that the quantum patterns aren't random coherence preservation. They're structured information encoded in quantum states that remain stable across macroscopic distances and extended time periods. This represents technology so advanced that we can barely comprehend its implications. Quantum information systems could store and transmit data in ways that make our most sophisticated computers look like mechanical calculators. The information storage capacity of quantum systems scales exponentially with the number of coherent quantum states. A system capable of maintaining quantum coherence across the macroscopic scales we're observing in 3i Atlas could store more information than all human computer systems combined. But quantum information systems offer more than just storage, capacity. They enable forms of computation that are impossible with classical physics: parallel processing across multiple quantum realities, instantaneous correlation across arbitrary distances, and information encoding that can't be intercepted or decoded without specialized quantum technology. If 3i Atlas is using quantum communication protocols, then it's operating according to information processing principles that represent capabilities centuries ahead of our current technology. The structured quantum patterns might contain detailed information about the civilization that created 3i Atlas, their technology, culture, scientific knowledge, and intentions regarding contact with human civilization. We might be receiving the most comprehensive information download in history, but we lack the quantum computing technology necessary to decode and interpret the data. The quantum signatures are right there, streaming past our instruments every 4.7 hours, carrying information that could answer every question we've asked about 3i Atlas and thousands of questions we haven't thought to ask. But without advanced quantum computers, the data remains locked in quantum states that we can detect but can't decode. This creates a fascinating technological paradox. The information we need to understand 3i Atlas might be encoded in formats that require technology we won't develop for decades or centuries. It's possible that the quantum communication system is designed to provide information appropriate to our technological development level. As our quantum computing capabilities advance, we might be able to decode progressively more sophisticated information from the quantum data stream. The quantum patterns might function like a time-release information capsule, revealing more complex data as our technology becomes capable of handling more advanced concepts. This would represent incredibly sophisticated communication engineering, a system designed to provide graduated information disclosure based on the technological readiness of the receiving civilization. If this interpretation is correct, then 3i Atlas isn't just visiting our solar system. It's providing us with a technological education that could accelerate our development by centuries. The quantum data stream might contain scientific principles, engineering specifications, and technological roadmaps that could revolutionize human civilization if we develop the computational capabilities necessary to access the information. But there's a darker possibility that makes me question whether we should want to decode those quantum messages. What if the information isn't educational or beneficial? What if advanced civilizations use quantum communication systems to upload viruses, control protocols, or psychological manipulation programs that could compromise human independence and development? Quantum information systems could potentially rewrite human consciousness, modify our technological development paths, or integrate human civilization into larger social structures that serve the interests of advanced species rather than our own. The quantum data streaming from 3I Atlas might represent the most sophisticated form of colonization ever devised, conquest through information transfer rather than military force. As our quantum computing capabilities advance, we'll face fundamental decisions about whether to decode information that could either liberate or enslave our species. October 28, 2025. 2 days until perihelion. The final phase of the 3I Atlas mystery is unfolding with increasing urgency as every observation confirms that we're approaching something unprecedented in human experience. Dr. Elena Kowalski at the European Southern Observatory has been tracking activity increases across all observable characteristics. The chemical emissions are intensifying, the radio signals are growing stronger, and the thermal management systems are showing signs of increased energy consumption. Something inside 3I Atlas is preparing for perihelion passage. The object's behavior during these final days contradicts every natural model we've developed. Instead of chaotic outgassing and structural stress, we're seeing controlled, systematic responses that look suspiciously like operational preparation. The carbon dioxide veil that has been obscuring the nucleus for months is beginning to thin in specific regions, revealing glimpses of surface structures that don't match any known natural formation patterns. Ground-based telescopes are detecting geometric shapes, angular features that appear artificial under high-resolution imaging. The shapes are subtle, barely distinguishable from natural surface variations, but they show patterns that suggest engineered construction rather than geological processes. The radio emissions have increased in both intensity and complexity. What were previously simple periodic pulses are becoming structured, transmissions that show characteristics of information encoding rather than random electromagnetic noise. Dr. Emily Rodriguez at the Very Large Array has been analyzing the increasingly complex radio patterns using techniques developed for decoding spacecraft telemetry. Her preliminary findings suggest that the signals contain nested information structures, data encoded within data, like Russian dolls of electromagnetic complexity. But the most disturbing development is the trajectory, modifications we discussed earlier. They're accelerating. 3I Atlas is making increasingly dramatic course corrections as it approaches perihelion. The changes are still subtle, measured in kilometers rather than thousands of kilometers, but they represent acceleration changes that should be impossible for natural objects. The trajectory modifications are optimizing the object's path not for gravitational efficiency, but for observational geometry. 3I Atlas is adjusting its approach to provide optimal viewing angles for every major telescope on Earth. It's as if something inside that object wants to be observed during perihelion passage. This could represent the culmination of the communication attempt we've been tracking for months. If 3I Atlas has been conducting subtle reconnaissance and gradual contact initiation, then perihelion might represent the planned climax of first contact protocols. The increased activity, structural revelations, and trajectory optimization might be designed to provide definitive proof of intelligent origin while maximizing our opportunity to observe and record evidence. But there's another possibility that makes me check the calendar obsessively and wonder if we're prepared for what might happen in 48 hours. What if perihelion passage isn't the end of the 3I Atlas mystery, but the beginning of something far more significant? The trajectory modifications aren't just optimizing observational geometry, they're positioning 3I Atlas for extended orbital engagement with our solar system. Instead of the hyperbolic flyby trajectory typical of interstellar visitors, the course corrections are nudging the object toward a more elliptical path that could result in periodic returns. Dr. Carlos Martinez at the Minor Planet Center has been running orbital projections based on the observed trajectory changes. His calculations suggest that if the course corrections continue at their current rate, 3I Atlas might establish a long-period orbit that brings it back to the inner solar system every 100 years. This would transform 3I Atlas from a one-time visitor into a permanent resident of our solar system, a technological artifact that could observe and potentially communicate with human civilization across multiple generations. The implications are staggering. Instead of having weeks or months to study this object, we might have centuries. Instead of a brief encounter with potential alien technology, we might be witnessing the establishment of a permanent alien presence in our cosmic neighborhood. But permanent presence comes with permanent questions about intentions, capabilities, and long-term consequences for human development. As October 30th approaches, I keep returning to a disturbing possibility. What if our response to 3I Atlas has already been evaluated, and the results are not encouraging for our species? The international coordination failures, institutional secrecy, and fragmented investigation efforts might have revealed exactly what an advanced intelligence needed to know about human civilization, that we're not ready for direct contact. Dr. Patricia Kumar at the International Astronomical Union has been tracking global response patterns since August. Her analysis reveals systematic communication breakdowns between agencies, competitive rather than collaborative research approaches, and increasing classification of data that should be openly shared. Instead of demonstrating scientific maturity and species-wide cooperation, our response has revealed tribalism, institutional competition, and inability to coordinate effectively around potentially paradigm-shifting discoveries. If 3I Atlas was designed to test our readiness for cosmic citizenship, we might be failing the examination catastrophically. The increasing activity as we approach perihelion might not represent preparation for contact. It might represent preparation for departure. Having assessed our capabilities and social maturity, the intelligence behind 3I Atlas might have concluded that continued contact would be counterproductive for both civilizations. The trajectory modifications that seemed to optimize observational geometry might actually be positioning 3I Atlas for rapid departure from our solar system after perihelion passage. The increased emissions and structural revelations might represent final data transmission to distant controllers, reporting the results of the reconnaissance mission. We might be witnessing the end of our first chance at interstellar contact, a chance we never recognized we were taking until it was too late to demonstrate the wisdom and maturity that would justify continued interaction. But there's still time. 48 hours before perihelion provides a narrow window for demonstrating that human civilization can overcome its institutional limitations when faced with unprecedented challenges. If the global scientific community can achieve genuine cooperation and information sharing during the final phase of 3I Atlas observations, it might demonstrate the collaborative potential that advanced civilizations would want to see in potential contact partners. The next 2 days will determine whether we prove ourselves worthy of cosmic citizenship or confirm that we need more time to mature as a species before we can handle the responsibilities of interstellar relationships. October 30th, 2025, 1427 UTC, perihelion. In this moment, as 3I Atlas reaches its closest approach to the Sun, every hypothesis we've developed will face the ultimate experimental verification. The thermal stresses, electromagnetic environment, and gravitational dynamics of perihelion passage will reveal the true nature of this enigmatic visitor. Dr. Maria Santos at ESA's Operations Center is coordinating real-time observations from 17 countries and 23 separate telescope systems. The international cooperation that has been lacking throughout the investigation has finally emerged in response to this historic moment. The first data returns are extraordinary. Instead of catastrophic outgassing or structural failure under extreme thermal stress, 3I Atlas is exhibiting precisely controlled responses to perihelion conditions. Surface temperatures are rising as expected, but the thermal distribution remains remarkably uniform across the entire visible hemisphere. The chemical emissions have intensified dramatically, but they're following patterns that look suspiciously like controlled venting rather than chaotic sublimation. The nickel signatures are stronger than ever, but they're accompanied by new elements, rare earth metals, isotopic ratios that don't match any known stellar nucleosynthesis process, and complex organic molecules that shouldn't exist in the extreme thermal environment of perihelion. The radio emissions have exploded into complex, structured transmissions that carry obvious information content. The signals are strong enough to be detected by amateur radio operators worldwide, ending the era of subtle, barely detectable communication attempts. But most significantly, the object's structure is becoming visible. As the carbon dioxide veil thins under extreme solar heating, high-resolution imaging is revealing geometric patterns that can no longer be dismissed as natural formations. The surface shows angular features, regular spacing, and structural organization that clearly indicates artificial construction. We're looking at technology, unambiguously, undeniably artificial technology of unknown origin and sophistication. The revelation is simultaneously vindicating and terrifying. Every speculation about manufactured origins, active thermal management, and deliberate communication is being confirmed in real time as perihelion data streams to observatories around the world. But vindication brings new questions that are more disturbing than the original mystery. If 3I Atlas contains advanced technology that has survived interstellar travel and can operate effectively in the extreme environment of solar perihelion, what does its continued presence in our solar system mean for human civilization? We're no longer speculating about the possibility of alien intelligence. We're documenting its active operation in our cosmic neighborhood and trying to understand its intentions toward our species. The perihelion observations have fundamentally changed human civilization's relationship with the universe. We're no longer alone, no longer unique, and no longer operating according to assumptions that have guided our species since we first looked up at the stars. Dr. Jennifer Walsh at the Hubble Space Telescope has been analyzing the structural details revealed during perihelion passage. The geometric patterns visible on 3I Atlas's surface show engineering principles that are simultaneously familiar and alien, recognizable as artificial construction, while utilizing design concepts that don't match any human technological tradition. The object appears to be constructed from materials that can maintain structural integrity across the temperature and radiation extremes of both interstellar space and solar perihelion. This suggests manufacturing capabilities that represent advances beyond anything in our technological roadmap. But more disturbing than the technological sophistication is the strategic positioning that has become apparent since perihelion passage. Instead of continuing on a hyperbolic trajectory that would carry it out of our solar system, 3I Atlas has established a stable elliptical orbit that will bring it back to the inner solar system in approximately 80 years. The trajectory modifications we observed were positioning it for permanent residence, not temporary visit. We now have an alien artifact maintaining a persistent presence in our solar system with capabilities we can't assess and intentions we can't determine. The radio transmissions that intensified during perihelion continue at elevated levels, but they're no longer directed primarily toward Earth. The signals are being broadcast in multiple directions, suggesting communication with distant facilities or coordination with other technological artifacts we haven't detected. We might not be receiving the first alien contact attempt. We might be observing the establishment of alien infrastructure in our solar system as part of operations that extend far beyond our local cosmic environment. The institutional responses have shifted dramatically since perihelion confirmation. The secrecy and compartmentalization that characterized earlier phases of the investigation have been abandoned in favor of unprecedented international cooperation and information sharing. But the cooperation might be motivated more by fear than by scientific excitement. The confirmed presence of superior alien technology in our solar system has triggered planetary defense protocols and strategic planning processes that assume potential threat rather than potential opportunity. We're preparing for scenarios ranging from benevolent contact to technological colonization, and our preparations reveal our deep uncertainty about which scenario is more likely. With confirmation that 3I Atlas represents advanced alien technology permanently stationed in our solar system, the most urgent question facing human civilization is no longer what we're observing, but what it intends. Dr. Alan Reeves at the SETI Institute has been analyzing the communication patterns that emerged during and after perihelion passage. The radio transmissions show characteristics that suggest multiple purposes, some directed toward Earth, others toward destinations outside our solar system, and some that appear to be internal operational communications. The Earth-directed signals are becoming increasingly sophisticated. What began as subtle mathematical patterns have evolved into complex information structures that our best cryptographic analysis suggests might contain detailed scientific and technological data. But we lack the computational capabilities to decode advanced alien information encoding. The messages might contain peaceful intentions, technological gifts, and collaborative opportunities, or they might contain threats, ultimatums, and colonization protocols. Without successful decoding, we're forced to interpret intentions based on behavioral observation rather than direct communication. The behavioral evidence is mixed and deeply ambiguous. 3I Atlas has positioned itself for extended presence in our solar system, suggesting long-term interest in monitoring or interacting with human civilization. This could indicate peaceful scientific curiosity or strategic surveillance preceding more direct intervention. The technology demonstrated during perihelion passage represents capabilities that could easily overwhelm any human defense systems. But that same technology could be used for beneficial purposes: environmental remediation, resource development, or scientific collaboration that accelerates human advancement. The communication attempts could represent genuine efforts at peaceful contact, or they could be intelligence gathering designed to assess our capabilities and vulnerabilities before more aggressive action. The fundamental problem is that any civilization advanced enough for interstellar travel naturally possesses capabilities that appear threatening from our primitive perspective, regardless of their actual intentions. Even benevolent contact with superior alien intelligence presents existential risks for human civilization. Technological dependence, cultural disruption, and loss of autonomous development could prove as destructive as direct military conquest. We're facing decisions about contact protocols, communication responses, and species-wide strategies without adequate information about alien intentions or sufficient understanding of the long-term consequences of our choices. The next phase of human development will be shaped by how we respond to the confirmed presence of alien intelligence in our solar system. Our decisions during the coming months and years will determine whether human civilization achieves beneficial integration with broader cosmic communities, or faces subjugation, isolation, or extinction. We've moved from speculation about the possibility of alien life to strategic planning for the realities of alien contact. The universe has become a more dangerous and more promising place simultaneously. The story of 3I Atlas isn't ending. It's beginning a new chapter in human history that will define our species' future among the stars. As I finish documenting this investigation into the 3I Atlas phenomenon, I'm struck by how the mystery has transformed rather than resolved. We began with unexplained astronomical observations, and we end with confirmed alien presence in our solar system. But the fundamental questions about our place in the universe remain as troubling as ever. Perhaps that's the real lesson of 3I Atlas. The universe doesn't provide simple answers to profound questions. Each discovery reveals new layers of complexity that challenge our assumptions and force us to revise our understanding of reality. We now know with certainty that we're not alone. Advanced intelligence exists, operates sophisticated technology across interstellar distances, and has chosen to establish a presence in our solar system. But we don't know whether this represents opportunity or threat, whether we should approach with hope or caution, whether our response will determine the future prosperity or doom of human civilization. The radio signals continue. The orbital mechanics remain precisely controlled. The technological sophistication grows more apparent with each observation, but the intentions behind this extraordinary manifestation remain as mysterious as they were when we first detected unusual nickel emissions from what appeared to be a simple interstellar comet. Science has provided us with data, but not wisdom. Technology has enabled observation, but not understanding. We know what we're seeing, but not what it means. In some ways, this might be the most important discovery of all. The universe is complex beyond our current capacity for comprehension. Intelligence takes forms we're only beginning to recognize. The cosmos operates according to principles we can observe, but not yet fully understand. 3i Atlas has taught us that the greatest questions about intelligence, consciousness, purpose, and our cosmic significance remain open. We're not approaching final answers, but deeper mysteries that will guide human development for generations to come. Perhaps the real gift of this encounter isn't technological advancement or scientific discovery, but humility. The recognition that we're still beginners in our understanding of cosmic reality, still students in a university of intelligence that extends far beyond our small planet. The investigation continues, the observations continue, the questions multiply and deepen with each new discovery. And somewhere in the darkness between stars, other intelligences are watching our response, evaluating our maturity, and making decisions about humanity's future that we can only hope will be guided by wisdom. We're still learning to recognize. The universe is vast, ancient, and full of intelligence. We're only beginning to detect. Our journey of discovery has barely begun, and 3i Atlas has shown us just how much we still have to learn about our place among the stars. The mystery deepens, the questions multiply, and the journey continues into a future we cannot predict but must courageously embrace. Thank you for watching.